So dear students, in this video I am going to discuss numerical problems appeared in the year March 2018. Watch full video that helps you to score more in the upcoming examination. Okay, so without wasting the time, let's get started. Let's have a look on the very first problem. That is, three charges each equal to 4 nanocoulomb are placed at the three corners of a square of side 2 cm. Find the electric field at the fourth corner. Here you can see the three identical charges, that is 4 nanocoulomb, are placed at the three corners of a square of side 2 cm. Let me consider a square of side ABCD, which is having a side A centimeter. Let us consider this is A. And let me place the charge, that is positive Q, at the corners A, B, C. And because of these three charges, there will be an electric field at the point D in this direction. That is, this is the electric field due to the charge placed at A, and this is an electric field due to the charge placed at B, and one more electric field will come place due to the charge placed at C. So now let me name them as E1, that is E1 is the electric field due to the charge placed at A, and E2 is the electric field due to the charge placed at B, and E3 is the electric field due to the charge placed at C. And you can observe that here E1 and E3, they are acting at an angle of 90 degree, and resultant of these two, that is E1 and E3, can be considered as E4, which is acting in the direction of E2, that is E4. This can be considered as E4 because this E4 is the resultant of E1 and E2. Now we need to find out net electric field, that is total electric field at the fourth corner. That is total electric field at the fourth corner is equal to how much? E4 plus E2. E4 is the resultant of E1 and E2. Now let me focus on the given data first. So here we have the charge Q equals to 4 nanocoulomb, and A, that is the side 2 centimeter. So let me write centi has 10 raised to minus 2 into 10 raised to minus 2 centimeter. We know that in the square all the sides are equal, so we could write here AB equals to BC equals to CD equals to AD equals to 2 into 10 raised to minus 2 centimeter. And the diagonals also are equal, that in the square the diagonal is equals to A root 2, that we can write. In the diagonal we can write like this. By using Pythagoras theorem we can get like this, that is A root 2. By using Pythagoras theorem we can get AC is equals to A root 2, that is equals to, here we have A, that is 2 into 10 raised to minus 2, so it will become BD equals to AC equals to 2 times root 2 into 10 raised to minus 2 meter. Now here E1 is equals to E3. Because of what is an E1 is equals to E3, we could consider because AD is equals to BC. The distance of point of consideration D is at the same distance, that is from A and as well as from C, it is same, that is AD equals to CD. So we can write E1 equals to E3, and moreover they are acting at an angle of 90 degree. If the two vectors are acting at an angle of 90 degree, then the resultant will be equals to how much? E1 root 2. So we know that whenever the two, let me consider this E1 and E3, they are acting at an angle of 90 degree. Now E4 is the resultant, so that can be written as like this. We know that the E4 is equals to square root of E1 square plus E3 square plus 2E1 E3 cos 90, because they are acting at an angle of 90 degree, because these two are vectors, so we can use like this. That is E4 is equals to E. We know that E1 is equals to E3, so we could write here 2E1 square, and this will become completely 0. So square root of 2E1 square. So that becomes E1 root 2. So I have written here directly E4 equals to E1 root 2. This is the electric field, that is E4 is equals to E1 root 2. We know that the net electric field is equals to how much now? E2 plus E4, because we need to find out net electric field at the point D. As we know that the net electric field is equals to how much? E2 plus E4. Why we have taken plus? Because both are acting in the same direction, so we could consider here E2 plus E4. So now you substitute the E4, that is E4 is equals to, just now we found E1 root 2, so we could write here E1 root 2. So that is E2 plus E1 root 2 it becomes. Now in substituting the equation, that is E2 is equals to 1 by 4 pi epsilon naught q divided by bd square. plus E1 is equals to 1 by 4 pi epsilon naught q dot by AD square, because we know that E equals to 1 by 4 pi epsilon naught q dot by square root of point of concentration. So here the square root of point of concentration, that is BD square, BD, that is E2 is due to the charge placed at Q, so we could write BD is square plus 1 by 4 pi epsilon naught q dot by AD square root 2. Now on simplifying this, we get q dot by 4 pi epsilon naught is common in both, so I can take them outside, that is q dot by 4 pi epsilon naught. If I take them outside, then I'll get q dot by 4 pi epsilon naught 1 by BD square plus root 2 AD square. Now BD is equals to how much here? A root 2. Just now we took BD equals to A root 2 and AD equals to A, that is the side. Now you substitute all the values. This is A, the given data, and Q also they mentioned in the problem, A also they mentioned in the problem. Just you substitute and simplify, go on simplifying, you'll get the net electric field at the point D or at the fourth corner. Okay, so here I'm substituting 1 by 4 pi epsilon naught value is 9 into 10 raised to 9 and Q value is 4 into 10 raised to minus 9, and here A value is 2 into 10 raised to minus 2, and here E equals to 2 into 10 raised to minus 2 substituted. Now go on simplifying this one. When you simplify, we get the net electric field at the fourth corner, that is equals to 17.226 into 10 raised to 4 Newton per coulomb. So in this way we can solve the problem. Okay, so let's look at the next problem. 100 milligram mass of nichrome metal is drawn into a wire of area of cross section 0.05 millimeter square. Calculate the resistance of this wire. Given density of nichrome is 8.4 into 10 raised to 3 kg per cubic meter and resistance of the material has 1.2 into 10 raised to minus 6 ohm meter. Here we need to find out resistance of the wire. Here we have a mass of 100 gram, that is, let me write here given data first. We have a mass of the wire, that is mass of nichrome metal. We have a mass of the nichrome metal that is equals to 100 milligram. This should be expressed in SI unit, that is it should be in kg. So 100 milligram is nothing but milli means 10 to the power of minus 3. Gram in terms of kg, if you write gram, then it becomes 10 to the power of minus 3 kg. So this becomes how much? Here 100 10 to the power of minus 6. It will become 10 to the power of minus 4 kg. This is the mass of the nichrome metal, which is drawn into a wire of area of cross section. Now area of cross section is 0.05 millimeter square. So millimeter square 0.05 into milli 10 to the power minus 3, it is square. So millimeter square is nothing but 10 to the power minus 6 meter square. This is equals to 5 into 10 raised to minus 8 meter square it becomes. Okay, now one more thing we have here, that is density of nichrome, that is density of nichrome we have, that is equals to 8.4 into 10 raised to 3 kg per cubic meter, and the resistivity of the material is 1.2 into 10 raised to minus 6 ohm meter. As we all know that the resistance is equals to resistivity into L divided by area. This is the formula for resistance in terms of resistivity and area of cross section and length of the wire. Now let me express this resistance in terms of a given data. So here we know that the resistivity we have and area of cross section we have, but we don't have length. So length must be expressed in terms of mass. Let me write here. We know that the density is equals to mass by volume. This volume can be considered as area into length, area of cross section into length. So now we could write here like that, that is the length of the wire can be written as, so we can write length can be written as m divided by d times area of cross section. Now in place of L, so we know rho, resistivity know, and as well as area of cross section we know, but we don't know L. So let me write L here, that is m divided by d times area of cross section. So now it becomes R is equals to rho m divided by d a area square, that is a square. Now substitute all the values. So that is, we know that density of the nichrome, resistivity, mass, as well as area of cross section. So after substituting, what will happen? Let us see now. Resistivity is equals to, here we have rho, that is 1.2 into 10 raised to minus 6 into mass, that is 10 to the power minus 4 divided by T, that is 8.4 into 10 raised to 3. The area of cross section, the area of cross section 5 into 10 raised to 5 into 10 raised to minus 8 whole square. So on simplifying, we get, that is R is equals to 1.2 into 10 to the power minus 10 divided by 8.4 into 10 raised to 3. Here 5 square, that will become 25 times 10 raised to 88, that is minus 16. So this becomes 1.2 into 10 raised to minus 10 divided by 25 into 8.4 to 10 into 10 raised to minus 13. Now R is equals to 0.005714 into here 10 to the power minus 10, and here we have 10 to the power minus 3 in the denominator, so it becomes 10 to the power plus 3. So therefore we can write R equals to 1, 2, that is 5.714 ohm. This is the resistance of the given wire. Okay, let's move to the next question, that is, a circular coil of radius 10 centimeter and 25 turns is rotated about its vertical diameter with an angular speed of 40 radian per second in a uniform horizontal magnetic field of magnitude 5 into 10 raised to minus 2 Tesla. Calculate the maximum EMF induced in the coil. Also find the current in the coil if the resistance of the coil is 15 ohm. So here we have a coil of radius. Let me write first given data. The radius is how much here? 10 centimeter. 10 centimeter, that should be written as meter, that becomes 10 to the power minus 1 meter, because centi means 10 to the power minus 2, 10 to the power minus 2 into 10, 10 to the power minus 1 meter. Next we have a number of turns, that is n is equals to 25 turns, and is rotated about an axis for angular speed. We have omega here 40 radian per second in a uniform horizontal magnetic field of magnitude, that is B equals to 5 into 10 raised to minus 2 Tesla, and calculate the maximum EMF of the, so we need to find out E, that is equals to maximum EMF. Also find the current in the coil if the resistance of the coil is 15 ohm. So we need to find out current if the resistance equals to 15 ohm. Right, resistance equals to 50. So now we know that an EMF induced at any instant of time is equals to E equals to E naught sin theta. E equals to E sin theta. That is the formula, that is instantaneous EMF equals to E naught sin omega t, where E naught is equals to N AB omega. This is the maximum EMF. So for maximum EMF, sin theta should be equals to how much? For maximum EMF, sin theta should be equals to 1. So this becomes now E equals to E naught, that is in place of E naught we could write NEAB omega. This is E naught is the maximum EMF, that NEAB omega. So E equals to N here 25 The area of cross section of the wire is pi r square. Let me write here n. A means pi r square, it is pi r square, and b omega. Now let me substitute n. In place of n I have substituted 25. In place of pi I should write 3.142, and r square, here r means 10 to the power minus 1 whole square, and b, that is the magnetic field, 5 into 10 raised to minus 2, and omega is equals to 40 radian per second, that is 40. I'm simplifying, we get 15710 into 10 raised to 10 to the power minus 2 into here 10 to the power minus 2, it becomes 10 to the power 4. So this becomes, so therefore you can write EMF is equals to 1, 2, 3, 4, so that is 4 decimal place, is 1.571 volt. This is the EMF, that is maximum EMF induced in the coil. Now let me find out the current. We know that the current is equals to, that is EMF induced divided by resistance of the coil. So we know that EMF induced is 1.571 divided by resistance, that is 15, that is equals to 0.1047 ampere. This is the current induced in the coil. Okay, so moving to the next question, that is, in Young's double slit experiment, the slits are separated by 0.28 mm and the screen is placed at a distance of 1.4 millimeter away from the slits. The distance between the central bright fringe and the fifth dark fringe is measured to be 1.35 centimeter. Calculate the wavelength of the light used. Also find the fringe width if the screen is moved 0.4 meter towards the slits for the same experimental setup. So first let me write the given data. Here we can see the slits are separated by 0.28 meter. That is, you can see that 0.28 millimeter. Here the small d, that is the distance between the two slits is small d, that is 0.28 millimeter. Milli means 10 raised to minus 3 meter. Next, screen is placed at a distance of 1.4 meter. That is the distance of the screen from the slit, that is represented by the letter capital D, that is equals to 1.4 meter we have away from the slit. The distance between the central bright fringe and the fifth dark fringe, that is distance of the fifth dark fringe from the central fringe is 1.35 centimeter. That is distance of the fifth dark fringe from the central bright fringe is 1.35 centimeter. Centimeter means 10 raised to minus 2 meter. We need to calculate wavelength of the light used. Let's calculate wavelength and also find the fringe width. So we need to find out fringe width. If the screen is moved 0.4 meter toward the slits, if it is moved 0.4 meter towards the slit, then distance of the screen and the slit, the distance between the screen and the slit is equals to d minus 0.4 becomes. So we know that d equals to 1.4, that is initial distance is 1.4 minus 0.4, this is equals to 1 meter. Whenever the distance between the slit and the screen equals to 1 meter, at that time what will be the fringe width? These two we need to find out. So we know that the distance of the nth dark fringe is equals to 2n minus 1 into lambda at capital D divided by 2d. This is the formula for the distance of the dark fringe from the central fringe. Suppose if it is a bright fringe, then what would happen? It will become P equals to n lambda d divided by d. But here we have a dark fringe, so we should use 2n minus 1 lambda d divided by 2d. So if it is bright fringe, you must use n lambda d divided by d. So we could use only this one, that is what 2n minus 1 lambda d divided by 2d, because here we have dark fringe. Now take lambda as a subject formula from this, so it gives that is lambda is equals to here x 5, that is distance of the fifth bright fringe from the central fringe, into 2d divided by 2n minus 1 into d. Now substitute the values. So if I substitute the given values, then we will get the lambda. Here x5 equals to, that is the distance of the nth dark fringe from the central fringe is 1.35 into 10 raised to minus 2 into 2 to d. D equals to 0.28 into 10 raised to minus 3 divided by 2 into, here n is equals to 5 minus 1 into capital D. Capital D equals to 1.4. On simplifying this, we get lambda equals to 0.06 into 10 raised to minus 5 meter. And this can be written as, that is lambda equals to, see here we could write this one as 6000, that is 1, 2 and 3, that is 6000 into 10 raised to minus 10 meter, and this could be written as lambda equals to 6000 angstrom. Okay, this is the wavelength of the light used in this experiment. Suppose if the distance of the screen is moved 0.4 meter toward the slit, then distance between the slits and the screen is equals to 1 meter. So by using the formula of fringe width, that is beta equals to lambda d divided by d, we can find out the fringe width, that is lambda equals to, let me write d dash here, lambda equals to 6000 angstrom, 6000 into 10 raised to 10 into d dash equals to 1 meter divided by small d, that is 0.28 into 10 raised to minus 3. So after simplifying, we'll get beta is equals to 0.14 millimeter. This is the fringe width obtained when the distance of the screen is moved 0.2 meter toward the slits. Okay, so moving to the next question, that is light of frequency 8.41 into 10 raised to 14 Hz is incident on a metal surface. Electrons with their maximum speed of 7.5 into 10 raised to 5 meter per second are ejected from the surface. Calculate the threshold frequency for photo emission of electrons. Also find the work function of the metal in the electron volt. In electron volt. Given Planck's constant and mass of the electron. So here, let me write first given data. Here we have a frequency of incident radiation, that is frequency, that is mu equals to 8.41 into 10 raised to 14 Hz. And the maximum speed of the photoelectrons is 7.5, that is V maximum is equals to 7.5 into 10 raised to 5 meter per second. We need to find out work function as well as threshold frequency, that is threshold frequency mu naught we need to find out, as well as threshold frequency, that is psi naught. From the Einstein's photoelectric equation, we can write the total energy of the incident radiation is equals to work function plus kinetic energy, that is total energy of the incident radiation is used in two ways, that is some part of the energy is used as work function and the remaining part of the energy is used to give the kinetic energy for the ejected electrons. So now we can write E equals to h nu, and work function can be written as h nu naught plus kinetic energy equals to half mv square. Let me write, if it is maximum kinetic energy, then it will become maximum velocity square. Now we need mu naught because we need to find out here threshold frequency. Here mu naught is the threshold frequency, so make this one as a subject formula, so that we can write h nu naught is equals to h nu minus half mv square. So this can be written as, now mu naught equals to h nu minus half mv maximum divided by h. So this becomes, that is mu naught equals to nu minus 1 by 2 mv maximum. Now we can substitute all the values, that is mu naught is equals to new. Here the given data is 8.41 into 10 raised to 14 minus half into mass of the electron. Here we know that 9.1 into 10 raised to minus 31 into velocity, maximum velocity of the visible electron 7.5 into 10 raised to 5 meter per second. So on simplifying this, we will get mu naught equals to 4.547 into 10 raised to 14 hertz. This is the threshold frequency. Now let us find out the work function. So we know that work function is equals to, that is work function equals to h nu naught. So just now we found here nu naught, that is the threshold frequency. H value is 6.625 into 10 raised to minus 34, and nu naught, that is nu naught equals to 4.547 into 10 raised to 14. So on simplifying, we get work function equals to 30.124 into 10 raised to minus 20 joule. But this should be expressed in electron volt. So let me divide this by 1.6 into 10 raised to minus 19. Then it will become electron volt. Now in terms of electron volt we need to express. So on simplifying this, 1.88 electron volt. Okay, this is the solution for this problem. Okay, thank you, thanks for watching.